Good morning, Grid Connections listeners, and welcome back to Season 7 of Grid Connections, the podcast where clean energy, electric vehicles, and the grid converge. Joined again today by Tom McCalmont, the CEO of Paired Power, to explore how microgrid EV charging can transform the way we power transportation. From solar-powered chargers and battery-backed systems to intelligent load management and vehicle-to-grid capabilities, Tom walks us through how Paired Power is solving the growing grid capacity challenge with scalable, resilient infrastructure. If you've ever wondered how to make workplace charging reliable, offset peak demand costs, or build energy independence with solar and storage, this episode is a must listen. Tom also gives us a live demo of Periscope, their powerful design and monitoring tool that models energy savings and charger performance all in real time. I will also say in advance apologies for the audio on my side if it doesn't always sound great. My allergies were in full swing and definitely left me a bit congested for this interview. Also, this conversation is brought to you, as always, by Grid Connections Consulting, helping businesses and communities accelerate clean energy and electric vehicle adoption with strategy, insights, and action. Plus, if you enjoyed this episode, share it with someone who's passionate about the future of energy, and don't forget to leave a review to help others discover the show. Sign up for our newsletter using the link in the show notes to stay connected with the latest in electric vehicle, energy, and infrastructure innovation. With that, enjoy. Tom, thanks again for coming on. And real briefly, if you could just kind of share a little bit about yourself and background for those who may be listening who aren't familiar.
Yeah, good, Chase. It's really great to be here again. I enjoyed the last time we had a chance to chat. Yes, Tom McCalmont and Paired Power. I've been actually in the solar space for 25 years, and I've been in the EV space for about, a dozen years. So lots of experience in both. What Paired Power does is we call it microgrid EV charging. There are many benefits, and I'll talk about this during our session today, where if you add a little bit of solar power to your EV charger project, you can get some enormous benefits out of that. Reduced cost, more efficient use of energy, resiliency, things like that. And so what that really is creating a microgrid. It's putting together different sources of energy to not completely eliminate the existing utility grid, but to augment it and get more capacity out of it. So that's what we do, and we have a bunch of really interesting products in that space. And I look forward to the conversation here today.
Yeah, and I think, so let's talk about where Paired Power is as a company right now and kind of like what, if I'm a listener or if I'm either just an EV driver or someone who may be interested in trying to augment with solar, how can Paired Power help me? And what are some of the things that your company is offering today for those
Yeah,
listening?
so great question. Let's take it from both viewpoints. First, from the viewpoint of the driver. Drivers are actually kind of frustrated. And the reason is if you go out on the highway and you use a whole bunch of EV chargers, you're going to find reliability problems. And so we've really invested deeply in making our systems very robust and providing connectivity in every system that allows us to monitor it 24/7. So we always know if a charger is operational, if there's a problem with it. We can often diagnose and correct problems remotely. So from the driver's perspective, we give a much, much better experience. And we hear that from users all the time. And from the site host perspective, there are many challenges for site hosts today, and particularly in places where EV adoption is high. We happen to be in California. There's a lot of EVs here, a lot of growth in the industry. A lot of workplaces are now adding EV chargers, and a lot of fleets are looking to convert their fleets to electric vehicles. And what they're all kind of universally finding is as you start adding large numbers of chargers, you run out of grid. You just run out of capacity. So what are your choices? Well, you can kind of live within the constraints of your existing grid, which means live within the constraints of whatever is delivered to your building if you're a commercial entity. But that will limit the number of chargers you can put in. Or you can go to your utility and say, I need more capacity. And the utility will do that, but it's a very, very long queue. Currently, it's about a 3-year wait in most of the utilities in California. It's similar in other high demand states. The utilities are at capacity. They're trying to build more capacity for data centers at the same time that they're trying to build more capacity for EV charging. And there just isn't enough capacity to do that quickly. And so it takes time to put those lines in, procure those transformers, put in those switch gears. All of that takes time. So we offer a solution that allows customers to do that with the grid they already have. We live within the constraints of the existing grid, and I'll give a little discussion about that and demo of that, how we do that. But that really is the secret sauce, is being able to help customers with that problem.
And is that kind of how a lot of customers are coming to you today, that they're kind of running into these power issues on site? Or is it kind of they're kind of curious? I mean, I think a lot of people, when they start driving electric vehicles, that is kind of like the end goal, is like, wow, what if I could just take the power from the sun and have it right there instead of having to deal with the
Yeah,
utility?
yeah.
I'm just kind of curious, like if you can share like what you're seeing around who is coming to kind of work with your team, or if it's just an open curiosity kind of earlier in the prospecting
Yeah,
phase, I guess.
we get lots of interest from people who have that problem I described, which is limited grid. They don't have enough capacity.
Yeah.
But there's also a lot of interest from people because we are truly a microgrid. So we're combining solar. Typically, there's some energy storage. Typically, there will be a grid connection as well. We're combining all three of those to serve the load, whatever the load may be. Typically, the load is electric vehicles. But in some cases, you may not have existing grid. You may be at a park or a beach or some place that's remote, which really doesn't have any capacity. And so then in that situation, we can also deliver off-grid charging solutions. We can deliver a solution that's powered purely by sunlight for charging EVs.
That's great. Well, I know you have kind of additional information and kind of some data and stuff you want to share with us. So maybe this is a good point to just kind of hop into that. And then for those listening, we'll try to do our best to kind of go through and kind of describe what is being shown on these slides. And then you can always find it online on our YouTube page as well.
Yeah, good. Thank you. And I appreciate the little intro there. For those of you who might be listening on a podcast and don't have visual access, we'll try to describe what we're showing here. So what I'm going to start with is our design tool. And one of the things that's really important in a microgrid environment is you have to take into account kind of all of the energy flows that are occurring in your system. And so we use a tool that we call Periscope. Pair is spelled with PAIR because we're paired power. We pair solar with EV charging. And so what I'm doing in Periscope, I'm first going to just create a new project. And that's going to bring up a little wizard window. And I'm just going to put in an address here. It's an address here in Silicon Valley, 300 East Tasman Drive in San Jose, which I just happen to know is where Cisco is located. Cisco is not currently one of our customers, so I thought I'd just pick them at random. But they're certainly a large employer that you would find typical for the kind of project that we do. And you can see, for those of you who can see the screen, you see a map of Cisco's campus. I'm going to put it into satellite view. And you can see in satellite view, I can see all their buildings, and I can see kind of where their parking spaces are. And then I'm going to move the pair over to here and say that's where we want to put our project. So we're going to start with a location. Next, we're going to define our fleet. And so I'm bringing up a window that says add my electric vehicle group. So I'm going to click on that. And let's say Cisco wants to put in 100 chargers. So we'll click 100 electric vehicles. And
it seems like that's pretty dynamic. I mean, there's a number that popped up that showed 5,000. I mean, is that like essentially what your program can design up to, or even beyond maybe?
Absolutely, yeah. We can design any level. So the whole purpose of this design tool is to model what's the energy I'm going to need for this project. So, and I just picked 100, but it could have been any number, hundreds or thousands even of chargers. The next screen I brought up here is shows the capacity of vehicles. Vehicles get different amounts of range. So I'm just going to use the average EV. The average EV gets about 3.5 miles per kilowatt hour. So we'll click that. We'll say we have 100 average EVs. The time I'm going to charge them, this is for workplace charging. So they're going to be there from 8 to 5. And let's say we want to give each vehicle about 40 miles of range. Okay, so that takes 9 hours. And it tells me I'm going to need 89 32 amp level 2 chargers. And let's say that Cisco also has some transit vans that they use for deliveries. Maybe they have 4 of those. So we'll pick 4 of those. And we'll define transit van. Transit vans only get about half the miles per kilowatt hour of an average EV. But those can charge at night rather than at daytime. So let's say we're going to charge those from 6 p.m. to 6 a.m. And let's say those need 100 miles of range per day. So we'll define that. So now I've defined my vehicle group. 104 vehicles, 100 average EVs, 4 transit vans. Next, I define my grid capacity. How much grid do I have today? Well, let's say it's a 208 volt 3-phase connection. And let's say we have 200 amps of capacity. And that grid connection is available all day long. And let's just model the utility rates here for this location. Here it'll populate with PG&E. So we're in Cisco is in Pacific Gas and Electric's tariff in this location. And let's pick B20, which is probably the rate tariff they would be on for a large campus like that. So we'll go to...
I mean, that is pretty wild. I mean, this drop down menu just shows all the different options you can kind of do through Pacific Gas and Electric. And
Totally.
I know you kind of before the screen, you were also talking about how those examples were all AC charging. Is this something that you could do like an on-site DC fast charging? Or I mean, there's now even some kind of like DC low charging technologies too. I'm just kind of curious if these are separate or if that's something that this model can do as well.
So it will do them. So yes, we can provide level 3. And actually, as I go through and create the scenario, it will tell me the capacity of the chargers that I need. So if for example, if I had said instead of 4 transit vans, I need 100 transit vans, that would have definitely that I would need level 3 charging. But I picked this example to be level 2, but you could easily pick any other. So here we are, we're picking B20, that's the PG&E tariff. And you can see over here on the right, those of you who can see the screen, it shows the actual rates that are going to be charged under that tariff, both the energy rates and the demand. And demand is a very important characteristic for commercial electric bills. A lot of people don't really understand what demand is. Demand is instantaneous power. And so you can see from the screen here, those of you who can see it, demand can be very, very expensive. In period 4 here, demand is $48.55 per kilowatt. So very, very high cost. So I'll select that tariff. And now I'm going to go, I've defined my grid. Now I'm going to go define my solar. And so what the system does is based on what I've already input, it tells me what it thinks it's going to need. So it says the recommended solar size is 175 kilowatts. So I'll click that. And it produces a nice chart. So it's using NREL's database, that's the National Renewable Energy Lab, to assess the solar irradiance that's available at this location, at the location for Cisco in San Jose. And you can see it produced a little chart here. Solar irradiance varies throughout the year. It's more in the summer and less in the winter. So you usually get a typical bell curve like this. And it shows here what the annual energy that solar array will produce. It's 293,000 kilowatt hours. And then what's going to be the energy production on the best day and the worst day, and the daily average. So all that's taken into account in the design of the system. So now I'm going to go to the summary. In the summary, I'm just going to turn off 2 things to start with. So here's our scenario. So the red curve is the consumption, and that's the chargers. If those 100 vehicles all come to work at like 8 o'clock in the morning or thereabouts, and they all plug in simultaneously, if there's no load management for that system, that's going to put a very heavy spike on the demand of the energy for that facility. And that's going to trigger those high demand costs that I talked about. And so what this is showing here in this quick analysis is under the tariff that I selected, The annual energy
Wow.
costs are going to be about $400,000 just for those chargers. Now let's
Wow.
add intelligent charging to that. What is intelligent charging? Intelligent charging means, and this is what we do in our software, means we're going to not try to charge all the vehicles simultaneously. We're going to make sure that they all get that 40 miles of optimum range that was requested in the scenario over the course of a day. And so over that day, we're going to make sure all the vehicles get at least 40 miles of range, but we're not going to try to charge them all at once. And you can see that saved $283,000 annually. Now, if I add solar to that, I drop my bill from $400,000 to $62,000 for the entire year. I saved $350,000 in energy costs. So this is
Wow.
the power of combining solar and storage with the EV charging. And it brings it home in a really dramatic fashion.
Yeah, no, that's really impressive and really cool to kind of I think these are a lot of things we always talk about, but to kind of see it more visually and then have those immediate numbers start kind of bouncing around is really cool.
Yeah.
I guess one question to follow up on is you're saying, and it makes sense to say, hey, maybe we're not going to have all these cars might be plugged in, but we're not going to charge them all at once. Does that mean all the cars, the instant I charge, I might be getting like half a kilowatt, but I am getting a charge? Or does it
Correct.
mean some will be on charging or some will be off and then it kind of just rotates through them? Or is that kind of up to the site design as well?
We can actually program it for either of those, and I can show that a little bit later if we have time.
Oh,
Um,
okay.
but to answer your question, there are two charging modes. One is to share the power, so all of the cars get something, but they might not. They might only get as much as being produced in combination with the sun and the grid,
Yeah.
and that amount might vary throughout the day. Right in the middle of the day, it'll be higher than it is in the tail parts of the day. Or I can set it for priority mode. And priority mode is that some of the cars get charged in the morning and some of the cars get charged in the afternoon. So it works throughout the day to spread the load. And we can do either of those or mix those. So now I'm going to review the project, and I'm just going to create it. And so now we've shifted to the second part of the design mode. What I had just gone through was the wizard. And this is not a system in operation, but what this view shows is very similar to the view that we would show for a system in operation, which is to show all the elements in the system. We show the solar, we show the battery, we show the grid power, and we show the chargers. And so just to illustrate that last question you asked, Chase, right now we're in shared power mode. Okay, so as the sun varies throughout the day, if you look at the chargers, you can see that the amount of current delivered might vary a little bit based on what's available. If I go to priority mode, now in the morning, the first half of the cars are charging, and in the afternoon, the second half of the cars are charging. So that
That's
illustrates
very cool.
the two modes that you were asking about. And of course, we can vary this seasonally as well, because it does change a little bit from winter to summer. But the point is that this design has now taken into account the fact that we're going to deliver exactly what was requested. We're going to deliver 40 miles of range per car per day in this combination of energy resources.
Yeah, that's a really cool way to kind of visually show what is happening among all these systems and then being able to kind of go between them and change even the different either requirements or parameters of what's going on live. That's really cool.
I could show one more thing if you'd like, which would be the kind of the
Yeah.
monitoring portal that we use. So let me share that and remember how to do that again. Yep, there we go. So this is the dashboard of our system. And what this shows, very comprehensive view of power flows across a broad variety of chargers. Everything from real-time power flow, the sun, the grid, and the battery, how that's flowing to cars, equipment status. And here you see everything is normal and healthy, but it shows the chargers and all the components in the system to make sure those are operating correctly. Customer service calls and contacts as we hear from customers. We keep track of those. We score the sessions. You can see that everybody has given us 5 stars so far, so that's a good indicator for the day. Charging sessions and charger utilization, and if I hover over these, it'll kind of show me for different chargers how heavily they're utilized. The darker the color, the more heavily utilized the chargers are. And then finally, total energy distribution. And then we also have a revenue tab here for chargers and how they're used. It's just going to show the portal itself. And one final thing here. I can remember how to share. There we go. Yeah, so this is our site here in Campbell, California. And for those who can't see, what we're looking at here is a graph, and this graph shows the different components of the system. So right now I'm just looking at solar generation, and it's a gold curve. And so you can see about 6 a.m. this morning, the sun started to come up, and we had a little bit of cloudiness around 9 o'clock. And then it got bright and sunny from then on. And so this is a kind of a typical solar production curve. Let's go back to yesterday. You can see yesterday was a beautiful sunny day. So here's a perfect bell curve like you would like to see on a solar system in California. So now let's look at the grid. Actually, let's look at load. So load is how was our system here used? And we have 10 chargers here at our building. So how was the system used? And the blue curve that's popped up now shows that about 7 o'clock in the morning, the first car came, and then at about 8 o'clock, the second car came, and then it kind of stayed as a square wave for most of the day until cars started getting fully charged. And so that's the load partially mitigated by solar. You can see the solar didn't quite do all of it. So now I'll turn on.
But it offset a pretty healthy portion of it.
A big portion. But so now I'll turn on the battery. So the battery is kind of a teal colored curve. And you can see it started the morning at 6 a.m. It was at about 80%. This is on the right-hand scale here, 80% state of charge. And then basically helped augment the sun throughout the day to keep those chargers running. And the final piece is the red curve, which is the grid itself. And you can see the battery was pretty low yesterday at the beginning of the day. It was down to about 10%. But the grid came on at midnight and recharged that up to about 80%. And so then the battery was there to augment the charge session throughout the day. So that just gives a quick illustration of the kind of advantages and capabilities of our system. The design tool showed the advantage in terms of cost savings. And this shows the advantage of that connectivity that I talked about to make sure we have a very reliable system for drivers, because we're always collecting data all the time from our systems. So
when it is also a really cool thing of just like visually making it very easy to see what is going on and where the power is going, what's being offset by it. And it's really interesting looking at this graph. Obviously, solar did majority of the power, but there was still that gap. And then the battery really did fill it in. I'm kind of curious, are you, for a lot of the sites, do you recommend doing a battery now, or is it kind of just dependent? Or it just seems like this is such a clear visualization that the battery really, I mean, it charged, it got some power when power was really cheap from the grid, and then the solar did the rest. It kind of seems like it's almost a no-brainer looking at this, that's the path you would go with.
Yeah, that's right. And the design tool will help you decide whether to use a battery in a system, because it's optional. It's not required in every system. But there's two advantages to the battery. One is on costs, and you can kind of see that in this chart here today. You can see the grid power effectively stopped at about 1 o'clock, and we use no grid power from about 1 o'clock to about 7 o'clock. And the reason for that is that's the most expensive time of day. So we don't want to use grid power when it's expensive. So having the battery there to backstop and provide that energy when it's expensive is a huge benefit. The other good example is in scenarios where you have fleet vehicles that are charging at night. Uh, they may not have enough grid at night, but if you bank some of that solar energy into a battery in the daytime, now I can combine that battery energy with the grid at night to get what I need to charge all the vehicles. So those are the two good use cases for batteries. And there's just a lot of intelligence in the system. We extensively use AI in our systems to make intelligent decisions as the system operates. So it's collecting that data all the time and making good decisions about, you know, all the variables that may be occurring. How does the sun change from day to day? How do the driver charging patterns change from day to day? And takes that into account to do the right thing each day.
I mean, kind of looking at all this, and the one thing we haven't talked about, and obviously it can be kind of like hardware specific for vehicles and the chargers that a client might be using, but does your technology also kind of support like a vehicle to grid situation or some sort of thing like that? Or I know
Totally.
that it's being approached by a lot of different people kind of in different ways. So I realize too, if it's still a little bit early on your side.
No, we haven't. Let me go back to
Cool.
the design tool. I didn't show that earlier, but so I'm back on the design tool periscope, and I'm going to click on the pair here. And you can see one of the modes is an emergency mode. And the emergency mode is maybe there's some other use of the energy. In the example that you see on the screen, the building is the priority over the chargers. And so in an emergency, and let's say there's a time where the grid goes out, or the building has a backup system that needs to be powered, we can deliver all that solar energy back to the building or back to the grid and turn the chargers either off or down. But one of the things we can do is individually, I can click on the chargers that
Oh,
are
cool.
capable of V2G, and now they can add their energy to whatever support is needed for those other resources. So now you can see I turned on about 5 of these just to show it. 5 vehicles that are capable of doing V2G are now delivering their energy back, supporting the building as well. So yes, we do provide support for bidirectional charging.
That's cool. So, it looked like it alluded to it on one of the slides, but in this case, we've kind of talked about it as if it's like giving the power to an EV driver. I assume also there can be like, let's say you're a business, to keep it simple, we'll just say power is 10 cents a kilowatt hour and you charge 12 cents, like the 2 cents for uh, maintenance and other stuff. Does that figure into this whole kind of financial plan as to like what it maybe even recommends you should be charging people for power or something to kind of make it
Totally,
either profitable or at least self-sustaining, just to kind of figure out for any
absolutely,
long-term maintenance stuff?
yeah, and it's a really good point actually, Chase, because I make this point frequently when I talk to people. So if you're an EV driver, you're willing to pay a certain threshold for the energy that's delivered to your car, and a little bit depends on the scenario. If you're on the highway and it's a fast charging scenario, you might be willing to pay more for that, maybe 50 or 60
Right.
cents a kilowatt hour. But if you're at the workplace and you're just charging there, you probably won't pay more than you pay at home. And so it might only be 20 cents a kilowatt hour that you're willing to pay. And so solar really can provide a huge benefit, because now that offsets some of that expensive grid power that the site host has to buy. They're
Right.
essentially getting it for free from the sun. And so they can increase the margin in that, or the marginal transaction value in that transaction with the driver. So instead of paying all of that 20 cents to the utility, they can capture some of that and monetize some of that value.
Well, I mean,
So
even
yeah,
then, I'm open to paying that 25 cents. I mean, there is a premium unto itself because we've even seen this become a bit of an issue with some level 2 chargers that they're broken. And so, like, let's say it's 20 cents, but the company's charging me 25 cents. That's still a pretty healthy delta if I just know I'm getting reliable power.
that's
And
right.
when I go to plug in, it works. And still, even then, that's probably going to still be a decent savings over what gas would be.
That's
So I
exactly.
think there is definitely kind of a case to be made that
Yeah.
while I as a user won't say no to free,
Right.
um, I would probably prefer it to work when I go to plug it in versus like, well, it was
Yeah.
free for 6 months and then it broke or something happened to
Yeah.
it.
Yeah. And,
Which I totally understand. I think that kind of gets to a larger kind of industry and kind of where we are thought process to it versus how you guys approach it. But I think it's really cool to have that built in and show those ways that if you're a business owner, you can kind of approach it a few different ways.
I've thought a lot about this problem because, I'll give you an analogy. If you think back to 100 years ago when gas stations were kind of coming to the fore, there was no competing fuel source, right? There was just gas stations. And so people would pay whatever the gas cost. And
Right.
factored into that cost was maintaining the equipment, right? It had to be at that time. And I think one of the challenges we have in today's world with EVs is that maintenance cost is often not factored. And
Yeah.
so we end up with a lot of chargers that are out there that the maintenance isn't fully covered in some way. And so they aren't maintained in an operational state. And so the public gets frustrated when they use those. And so we believe a key part of the secret sauce to prevent that or to overcome that is this constant connectivity that I showed on the example here. If you have data coming from the stations all the time and you always know what's going on, and we can do all kinds of things with our system remotely. We can reboot it. We can install new firmware. If a charger gets stuck, we can get it unstuck. All kinds of things. We also have a very good communication path for the driver. So when they're interacting on their smartphone with the charger, they can just push a support button, be connected to our support center, and interact directly with a tech who tells them, guides them through whatever the issue might be. And so all of that helps improve the reliability and the response that the public has to the chargers.
Well, and I think that is a really valid point. It's a really interesting way to approach that. I think people are starting to kind of open up to. I think we just had kind of this first wave, and now we're kind of getting to a more matured market and just kind of
Right.
market realities of how to approach this. And I guess I'm curious, not to shift a little bit. I think this is. I guess before I do that, though, I just want to say it's so. I love the visual of this because I think there's so many people that when they're thinking of doing this, it's really easy for someone to talk to them about it who knows a lot. But if you're kind of coming in and you're curious about it, but you don't know a lot of this stuff, the visual aspect of it and kind of being able to play around with it and kind of walk through a lot of these scenarios, because there is still a lot of kind of misinformation, good or bad, about what like solar and a battery can actually do. And then you can kind of go through this and play and find the right system for you. But I'm kind of curious with all this technology we've kind of talked about, like before we went live, we were kind of talking about like the impacts of the tariffs and some of that stuff on the industry. I'm kind of curious to hear what you're seeing and kind of like the current state and kind of like future looking that Paired Power is kind of seeing for EV charging and the EV industry, and how your team kind of you think fits into that and some of the things you'd like to see.
Well, I'll make a couple of observations. There was an article in the New York Times just in the last couple of days, and the author was sort of expounding on is are EVs going to die the way they did 100 years ago? That was kind of their premise, because there were electric vehicles 100 years ago in the beginning of the
Right.
auto age, but they kind of died out. And I just don't believe that's going to happen, and for a bunch of reasons. To start with, the world market is growing. So regardless of what happens in the United States, all over the world, people are doing electric vehicles, even in places that are kind of thought of as not well developed, like India. All these little, I forget what they call them, these little carts that they drive around that spew diesel. A bunch of those are now converting to electric. And China is the leader in electric vehicles now. BYD is the largest supplier. They're exporting to Mexico, to South America, to Europe. So you just see all over the world that the growth is really there. And, kind of for me, what goes along with that is the experience is better. The driving experience, they're quieter, they're cleaner, they're cheaper to run. They're just a joy to drive. They're more comfortable. So once people try them and realize that's the case, they typically don't go back. And so I think the growth of the market will continue. I mean, it's unfortunate that the U.S. is taking a little bit of a negative attitude towards electric vehicles, but I don't think it will persist for long for those kinds of reasons. So I'm pretty bullish about it.
Yeah, and I think that's a totally fair call out. That in some ways there's we'll see what actually happens. But as of this recording, there's kind of been talk about removing the $7,500 tax credit for
Right.
electric vehicles, and I think there is actually a decent case to be made. Well, obviously it's nice and kind of helps spur it. I think it is a thing that there's a case to be made that maybe we should just get rid of them, and it just becomes like one less like thing that somebody can say, well, they're being incentivized, yada yada yada.
Right.
Because I think you wind back the clock only a couple of years, if that, and yeah, those incentives made a difference, but we're just seeing from the market. I think kind of to your point, that's just the part where I don't think we will see the same thing happen like we did 100 years ago. It's just the market price and the availability of electricity and everything else, and just the ease of use has really been figured out to a point that we just did not have 100 years ago.
No,
And
that's
it,
right.
it just has kind of went so many, I mean, it's one of the things I've kind of brought up on this podcast. And even when we were at the EV charging summit, I talked about this with a few people where it's just like, I think the industry got ahead of itself in a lot of ways. And one of those areas was the idea that you still didn't need to get like butts and seats in electric vehicles for people to have that kind of light bulb moment to understand that change and realize, oh, this is actually a
A way better experience.
way
Right.
better experience. I mean, there
Right.
is kind of like on paper, okay, maybe it saves me money. And then you see these things, oh, well, there's now these charges. Maybe it won't save me money. But then once you start driving around, you're like, okay, I guess I don't have to deal with brake changes as frequently or oil changes at all and all these other sorts of things. And then it really does start to click for a lot of people. And I think there's an element to that where
Yeah.
um, I think people, it might be easy to kind of have a negative mindset. But overall, I just don't think you can have that, especially when you look long term, but even like middle term. Um, just with how things have grown and we're starting to see these changes, it just seems like there's so much opportunity. And it really is just as simple as getting people into an experienced electric vehicle that starts to really change.
Yeah, and I think they do a lot of ride and drive events now, and I think those are really great because it does give people that first experience. I was probably a little bit skeptical myself. My first EV I bought in 2011, which sounds like a
Oh,
long
wow.
time ago if we could, but at the time I, I was a little skeptical the first time I drove one, and the first time I drove one it was a Nissan Leaf, and which today isn't thought of as a particularly sporty car, but it was way sportier than any other car I'd ever driven that was a gas car. And so I drove and I was like, well, this is fun to drive. And and so I bought it, and I had that car for about 5 years. I spent $120 on maintenance in 5 years.
Wow.
I think there were like 4 or 5 software updates. Each one was $20 each. That's all I spent on maintenance. That was it. And so I was like, okay, I was completely converted at that point. And I'm now on my sixth EV. No chance I'll ever go back. I just love it. So, and so other people will
Yeah, and
have
I,
this
I, I
experience.
totally agree. We have two electric vehicles, and then we have kind of a classic car thing that we use kind of on the weekends for like going off roading and stuff.
Right,
But yeah, I mean, like day to day, and I realize that even puts us kind of out having three cars. For most
right,
people, like having one car, it really has become a point where you can do that, especially if you live in a city. It's becoming much easier, much more straightforward for that process. And obviously, kind of what you guys do at Pair Power makes it really easy. If you work at a company that offers charging,
right, exactly.
just having that reliable spot that you can charge at is a huge, huge service.
Yeah. Yeah, and now the
When
cars are 250, 300 miles of range, so
right,
range anxiety has pretty much gone away. I used to have a little bit of range anxiety in the early years, but now I go all over the place. I never think about it. And you do start to learn that the charging mechanism or the fueling mechanism in an EV is a little bit different than it is a gas car. You don't really
yeah,
want to have to fill it up. You don't have to go to the quote unquote gas station to fill it. Instead, you just want to plug it in wherever you are, at home, at work, at school. Plug it in, walk away, do something else, and your vehicle is fueling while you're doing something else. So you don't have to wait. So somebody did an analysis and they concluded that the time people spend waiting at gas stations for their car in 10-minute intervals over the life of the car is actually more time than it takes to fuel an EV because it only takes 5 seconds to plug in and you walk away. So,
and no, and I know I've seen that as well, and I totally believe because I can even think of times where, especially when I was younger, I was just trying to be as cheap as possible when I had to fuel up. So I might go to a Costco, and especially in the summer, that could be like a 30-minute wait just to
Right.
fuel up at those prices, which in retrospect is kind of crazy to think about, but you still see those lines all the time.
Right.
And as long as you have even just reliable, accessible level 2 charging, that experience and those kinds of issues just kind of melt away.
That's right.
I'm kind of curious, like looking at where paired power is and kind of the future of it. I guess, can you share some of the things that you're like going through, like the evolution of it? Like, what were some of the things that, like, bringing all these together that either were really difficult or maybe even surprised you at how difficult it was? Because I feel like it's only within the last couple of years a lot of these systems were reliably talking to each other, if
Yeah,
that.
that's a
And
great
it just
question.
seems it's really fascinating to see all these kind of finally brought together in a really seamless way.
Yeah, let me talk about that a little bit. So we actually started a slightly different place. We had the original idea, could we charge EVs directly from solar? Just DC to
Yeah.
DC, just take it directly out of the solar canopy, deliver it into the vehicle. And we actually, our early systems, that is what we did. And we moved away from that eventually because it creates some challenges. And one of the challenges is there's no good DC standards still. There's still a lot of
Yeah.
conflict in that world. And so you have to support all the standards to kind of be effective. But the other thing we started to realize is that the battery can often have a number of benefits, and it can smooth out the power. It can, as I talked about, it can have economic value and reducing your electric rates. And you saw on the example, it can be thousands and thousands of dollars of savings. So that's when we said, let's convert and do AC charging. It's kind of ironic that even though we started in DC, we now do it with AC, although we can do level 3 as well. And but the advantages are just of that microgrid approach and the managed approach that I demonstrated in the software is really where the value is. And so we've pivoted to that, and that's what we're doing. We have two product lines. What we call pair fleet is a solution for large numbers of vehicles, so any number from 6 to hundreds or thousands. And then we have a smaller system we call pair tree, which just does two chargers, but it's pop-up. It's very quick to erect. It's designed to be installed in a single day. And so you like if a place like a park, for example, or a beach where there is no grid infrastructure, we can pop one of these up in a day and be providing charging resources at that location. So those are the two product lines: pair fleet and pair tree. And then, of course, managed charging for both of those, as I talked about.
That's great. I'm kind of curious with all of the technologies. I mean, we covered from vehicle to grid and a lot of the things that you do support today. Are there any other technologies or things that you're hoping to add or kind of in the future add support to? Because the more we talk through this, I'm starting to not be able to think of any that we haven't really covered. I mean, unless like maybe instead of solar, you could also do like a wind thing, but I realize the uh, locations and
Wind is great.
I guess I'm wondering if there's other kind of DC power things you could swap in for the solar. I mean, it should be straightforward enough. Really, you
Yeah,
just need a charge controller.
wind is really great for certain kinds of situations like offshore,
Yeah,
but it doesn't work very well in urban environments. So
right.
and solar is a lot more
Where
playful.
I live is very windy, so it's like one of the few places you could actually do it. But no, I completely agree with that. I'm just kind of
Yeah,
trying to think of things that you're looking to do or that you're excited to add to it.
yeah. So solar is an amazingly good resource across the entire
Yeah,
United States. Most people don't realize, if you sort of look at the capacity of different sources of energy around Earth, whether it be oil or nuclear or wind or solar, solar is by far the biggest and richest resource. It's many times as much available energy as anything else. So ultimately, it'll be a big winner for our energy resource. But we're looking at some really interesting things. There are a number of things you can do with microgrids beyond just EV charging. There's a huge amount of
yeah.
benefit to providing power in kind of remote applications or applications that only have partial grid, things like that. We're also doing some really interesting things to add kind of capabilities beyond what I've talked about in terms of blending of solar, grid, and EV charging. Some really, really innovative ideas. I will not. I'll just tease you and tell you they're coming, but I won't say what they are.
Well, we'll have to
Um,
have you back on to go over those then.
so,
Yeah, yeah.
but yeah, there's a lot we can do, and we view ourselves as the leader in this space. We really pioneered it. We have deep solar experience, and so we really understand how to blend it with other energy sources. And of course, there's a lot of interest in that now with other parties. But we think we bring a lot to the table in terms of what we can offer.
No, that's really cool, and it makes a lot of sense. I guess going back to what you were kind of talking about around the DC and then switching to AC, um, do you see that could ever change with kind of more and more things kind of going to the North American charging standard, the J3400,
Yeah,
or is it still just not as is that the biggest issue you ran into, or were there other issues as well?
yeah. I think what they call NACS, North American Charge Standard, or as it's now been tagged by SAE as J3400. Um, so that is a alternative to J1772, which is the standard interface. It might be the one that wins. It's
Yeah,
certainly. I think uh, there's a lot of appeal to the elegance of the connector. It's a very lightweight connector compared to the heavier connector of CCS,
yeah,
and so I think we'll see how that evolves in the market. It's still kind of early days, and there's still multiple
and that's
standards.
a good point.
Yeah,
Yeah,
but we can already support both interfaces, and we believe, at least for the near future, they'll both be important. Um, but it'll really probably be determined by the vehicles. And
yeah.
as vehicles, if they start to adopt the J3400 or adopt it in place of J1772, that may tilt the market in that direction. So, and I assume your audience probably knows that the NACS or J3400 was pioneered by Tesla. So, and they certainly represent a large percentage of the cars still. So,
That's true. I mean, as far as the actual percentage of cars on the road, it's still a large one,
right.
and part of the reason I bring it up is so many of the automakers have said they're going to support it, and now we're finally starting to see that with some of these models making it to market. With, I mean, I guess one thing to take a step back is obviously there are some inefficiencies and losses, but a lot of the time it's only like a few percent here and there. What in like a perfect situation, let's say you just do the J3400 NAX plug, what would be roughly the difference in like energy saved? Is it like 5, maybe 10% worst case, or is there a pretty decent delta in doing a fully DC charging experience from directly from solar?
So good question. There's two factors in that question that bear on it. Um, so a lot of people don't understand electricity very well, so I'll expound on this a little bit. So one is the wires. How big are the wires? How large are the physical conductors that are in that cable? Tesla uses a very thin wire, and so you're essentially constricting the flow a little bit. The electrons can't get through there as easily. You can't push as many electrons through a tiny wire. One way you can address that is by increasing the voltage. Most people don't understand this, but the same wire can carry twice the power if I double the voltage. So a lot of the cars that were developed first were 400-volt cars. Now the manufacturers are moving to 800-volt cars. So that allows me to push more power through that same cable. So that improves the efficiency. So that's one way to improve efficiency. So, yeah. So that I had a second thought, but it's escaped me for the moment. But I guess DC. So DC versus AC. The other thing that's really just astounding, and you can read some of the trade press for EVs now, some of the technical journals like Charge Magazine. The amount of innovation going on is just truly incredible. There is just a lot of really good innovation going on. And a lot of that is around efficiency. If you look at the kind of
Yeah.
components that are being developed, and these are power reduction or power transference semiconductors, those get more and more efficient. And so that efficiency curve gets better all the time. So you're correct. The DC is slightly more efficient than AC, but it may not be a meaningful difference as these
Yeah.
components continue to improve. So,
Yeah, and that's what I kind of thought it might be, but was just curious and wanted to check with you. I realized, Tom, we're kind of coming up a bit on the time here. So I do want to say thank you for coming on again, but I'm kind of curious if there's any upcoming events or any other things that for those listening that people may want to be aware of with Paired Power, or if what's the best way to kind of get a hold of you and the company.
yeah, well, thank you for the opportunity, Chase. We really enjoyed the conversation. It's always great to interact with you, and you bring such a high bar to these discussions, and I really appreciate that. Paired Power is Paired Power, PAIRED, pairedpower.com. All our products are listed on our website. There's a lot of good information there. There's places you can click on a link if you need more, and that'll get to the right people. So we'd love to talk to any customers who might be listeners, and really appreciate the opportunity to meet with you today. Thanks.
Yeah, thank you, Tom. And I know you teased some upcoming things, so we'll have to have you on again soon to find out what those new upcoming things that your team's looking to support. But thanks
Sounds
again,
good.
Tom, and talk soon.
Okay, take care, Chase. Thank you.
That wraps up another episode of Grid Connections. A big thank you again to Tom McCalmont from Paired Power for joining us and sharing how a microgrid EV charging is unlocking smarter, more resilient energy solutions powered by the sun. If this conversation got you thinking differently about solar storage and electric vehicle infrastructure, help us spread the word. Share this episode with one other person who'd find it valuable as well. And if you haven't yet, please leave us a quick review on your favorite podcast platform. It really does help make a big difference for our show so we can continue to bring guests on like Tom and many more for you to enjoy. To stay in the loop with the latest trends in clean energy, electric vehicles, and grid innovation, sign up for our new newsletter. Just click the link in the show notes. This episode, as always, was brought to you by Grid Connections Consulting, helping organizations navigate the evolving energy landscape and build toward a more electrified future. Until next time, this is the Grid Connections Podcast, signing off.